Okay, so today we're going to be doing question 733, flood fill on LeetCode. And what this question is asking is you are given an image represented by m by n grid of integers named image, where image at index I and j represent the pixel value of said image. You are also given three integers, sr and sc, and color. Your task is to perform a flood fill on the image starting from the pixel image at index SR and SC. SR and SC stand for starting row and starting column. So to go into more in depth in what this question is asking you, because the first thing you need to understand is what is a flood fill. So we have a starting row and a starting column that we are given within this function called flood fill. Right, and starting from the starting row and starting column, we want to begin at that said spot and change the color to whatever color we are given for this parameter. So we're right now changing the color of our starting area, and we want to perform the same process, which is changing that color for each pixel that is directly adjacent. So basically what this means is starting from the row of the original point that we're given, we want to be able to change all the colors for any value directly adjacent of the original, which is up, down, left, and right. So pixels that share a side with the original pixel, either horizontally or vertically, and share the same color. So this is another important aspect. So not only do we have to go up, left, right, or down, but those values have to share the same color as the original starting point to get access to change the color into something else. So if we're going up and the up value has the same color, we change it. If we're going left and the left value has the same color, we change it. If we go down, but the down value does not have the same color, we do not change that color. We want to process the stops where there are no more adjacent pixels of the original color to update. Return the modified image after performing the flood fill. So taking a look at our whiteboard, this here is going to be our unedited graph, right? And let's say we start here at 1, and let's even make the color, we will make the color red. So this is where we're starting here, and we want to, let's say, change, these are all blue, and we change the color to red, right? We want to go up, right, down, and left from the original starting point, right? And we need to check two things. We need to check if, like we mentioned, it's up, left, right, or down. And then we want to check if has the same color, right? Is the same color as a starting point, then we can change it. Then we can change those colors. So how's that going to look? Well, these are 1. Let's look up. Up, right, is the same value, right? So we're going to change this to red. And we're going to continuously be doing that. We're going to check left, same value. We change this from blue to red. And going to these points, we're able to branch off of them and continuously do the same thing. So let's say we start from the left. We just change this color. We can look up and down. Well, up is also the same value. So we turn this to red. We can look up here from this starting point. That's red. And now we go over here, right? We can go left, right, or down. Looking at right, the value is the same. So we change the color, right? But everything else we can't touch, because if we go from here and we take a look at the right, this is a 0, right? We can't change because they're not the same, so that stayed the same. And the same thing here, we should go down from the original starting row and column, and we realize that this is also not the same, so we can't change. This is how we get this answer, where it's practically the same thing, but the values just changed into 2. The reason why the values are changed into 2 is because in code-based languages, there's not necessarily a variable for color. So the colors are represented by numerical values, and the numerical values are 1, 2, and 0. So now as we have an idea of what we're doing, at least how we're starting from the original row and column, we're moving up, left, right, or down from whatever point we're in, and whether or not it's the same color, then we can change that color and that it connects. So now we need to figure out a way to write that in code and the thought process of how to achieve that. Well, the first thing that we're going to need to do is, if we have an original starting row and starting column, we're going to need to save that, so when we're checking all these other places, that they fit the description of the original color. So we're going to make a variable with the name original color, and we're going to set this equal to image, which is going to be our graph at index SR and ST, right? So now we have starting row, starting column, and we've saved this to a variable named original color. So this is our OG color, right? Oh, there you go, where we are starting. And we want to create an edge case, right? Because what we're actually going to be doing is using recursion. I mentioned previously a couple minutes ago that we are continuously checking and going through each kind of point within this graph or matrix. And in order to do that, we need to use recursion. When you're continuously doing something over and over again, right, recursion should be one of the first things that pops out of your brain. So if we're doing that, we obviously need to make an edge case. And the edge case is going to go if original color, right, is equal to the color that we want to change to, then there's nothing to do, right? We should stop dead in our tracks, because like mentioned before, if we do hit that color, then we should just return none, right? We shouldn't do anything. So we just return none, right? So this is basically saying, right, if the starting color, the starting color is the color we are changing to, return no. There you go. Okay, so now we have a variable to save the original color, and we have our edge case. Now we need to do recursion. We're going to create a helper recursive function, and we're going to just name this fill, because we are filling things out. And we're going to pass in two parameters, which are just row and column, right? And these parameter values are going to be given by calling fill and just passing in the starting row and starting column. There you go. Now we need to actually add things within our function. So what we need to do first, before filling out anything, is by creating basically just some if statements and base cases to make sure, right, / base cases, to make sure that whatever value we're on, right, kind of fits the description. And once they kind of fit all these checkboxes, then we can begin coloring. So we're going to check first if row is less than 0, or if the row is greater than or equal to the length of image, right? So this is basically just checking if we're out of bounds, right? Then we're just going to return none. And the same thing could be said if column is less than 0, or if column is greater than or equal to the length of image. And I believe we're going to do it index 0, right? And if we do this, it is the length of the first row when we do it index 0, right? So the beginning is basically saying if the row is less than 0 or the row is greater than or equal to the length of image, which is just the number of rows in particular, which are 3, right? In this example, you have 1, 2, 3. And then this is getting the length of the first row. So the length of the first row is 3, and it may be confusing, but this is length of the first row, which is 3. And then this is going to literally be our length, or amount of rows, number of rows. There you go. There you go. Now that helps everyone kind of understand what we're doing. And then last but not least, we are going to need to do another if statement. Oop. There you go. If image at index row and column, so wherever we may be within this graph, if this does not equal the original color, right, which keep in mind it needs to, right? If it's not, then we just stop, and then we just return none. Beautiful. So this is basically just saying if not OG color, return none. If none of these are checked, right, then we get to actually paint our row, right? And we do this by just setting image at whatever row and column we may be in and set it equal to color, the color that we want to change it to. And now we need to do the recursively to make sure that we go up, down, left, and right. So if we're doing something recursively, and this is a helper function, then we know for a fact that we're going to need to at least have fill, right? So we call the function, and we need to just add values into this parameter. And if we're going up, left, right, or down, we need to do this 4 times. So fill, 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 and fill. Beautiful. The first one is going to be moving up, so row, there you go, -1, and column. Then to go down, we just do row +1, column. And to go left, we're going to be messing with our column value, so it'll be -1. And then obviously vice versa, col +1. And this will be moving up. This will be painting up. This will be painting down. Oop. Not that. This will be moving left. And this will be moving right. Beautiful. We called our function, and all we need to do now is just return image, because after all of this, image should change, and we should be getting our new graph. So let's run this to make sure that everything is working. Okay, we are getting an error. Oh, I already see the error. We have a period here. Let's give this a run again. Okay, we have a null here. Let's do a double check on everything that's going on. Original color equals image at index starting row and starting column. The original color equals color, return, return image. Because this is just returning none. If it is, then we just want to return the whole thing. So let's give this a double check. Okay, now let's submit and make sure we pass all the test cases. There you go. Okay, golden. So to just do a recap on the question, we are right now just doing things recursively here. We have a list, right, of basically 3 columns, one consisting of 111, 110, and 101. We have a starting row and starting column, which is exactly where our point is going to be at, and we have a color, right? We want to basically check if the value is the same as starting row and starting column, and it touches, whether it be directly adjacent, so up, down, left, or right. We want to change the original color to the new color and continue that as we go. So if we go higher, to check the left and right of that value. If we go left, check the up and down value of that left value, and vice versa, and basically just spread and continue spreading for as long as, or as big as our image may be, right? And we need to make sure that we continuously do this, which is why we use recursion. This is why we have a helper function, and we're consistently calling the fill function. And you can see how we continuously are checking up, down, left, and right. That was the whole point of the recursive function, to kind of do these things right here. We need to make sure that we create our base cases within this function, which is why we have 3 of them here, making sure that if all of these are not met, right, then there's no reason to return none, and we paint our rows. It's also really important that we have this edge case here. This is the thing that I slipped up on. I forgot to return image and I just returned none, which is a no-no. We are basically checking here if the original color that we're on and starting on, so in this instance, it's here. If it's set equal to the color that we want to change these values to already, then there is no point, and all we do is return image because it's perfect the way it is, right? If this is not met, then we continuously basically just do this, we forget about this, and it should change into a whole new image.